Your phone is dead. You're 3 miles from the trailhead. Your car is parked at the bottom of the hill, and the portable battery pack you remembered to charge last week is sitting on the kitchen counter at home. You have no outlet. You have no solar panel. You have no generator. What you have is the ground beneath your feet, 2 pieces of metal from your pack, and a law of physics that has been generating electricity from soil for 150 years. This is not a survival fantasy. It is applied electrochemistry. And within 20 minutes of reading this, you will understand exactly how to pull a measurable, usable electrical current from any patch of moist ground on the planet using materials that cost less than $1 at any hardware store. The device is called an earth battery. It was patented in 1841 by a Scottish clockmaker named Alexander Bain, who used it to power telegraph lines across miles of open countryside without a single conventional power source. It was documented in official United States government reports filed with the Smithsonian Institution in 1848 as functional federal infrastructure. It was demonstrated publicly in Washington, D.C. in 1902, transmitting voice signals across the Potomac River, and it has been entirely absent from every survival guide, every emergency preparedness manual, every off-grid living resource, and every portable power product catalog published in the last 100 years. The global portable battery market generates over $150 billion in annual revenue. Every phone charger, every power bank, every disposable battery, and every television remote and smoke detector in every home on the planet is a product sold inside a system that depends on your believing that electricity requires manufactured technology to produce. An earth battery requires no manufacturing. It requires no fuel. It requires no maintenance. It draws its energy from the electrochemical potential difference between 2 dissimilar metals buried in moist, mineral-rich soil, a potential difference that exists everywhere on the surface of the earth, constantly for free, and that no corporation can meter, patent, or price. Welcome to $1 Miracle. This is where we explore alternative energy sources, often overlooked in mainstream narratives. If this kind of knowledge matters to you, subscribe now and hit the bell, because what I am about to show you will permanently change how you think about electricity, about batteries, and about what you actually need to survive when the grid goes down. Let me take you back to where this all begins. Not to a power plant, not to a battery manufacturing facility, but to a small workshop in Edinburgh, Scotland, in the year 1841, where a clockmaker with no formal scientific training was about to demonstrate something that the electrical industry would spend the next century pretending had never happened. Alexander Bain was 30 years old and obsessed with electricity in the way that only self-taught inventors can be. Without the academic boundaries that tell a formally trained scientist what is and is not worth investigating, he had been experimenting with electrochemical cells for years, building clocks powered by electrical current at a time when most people had never seen a practical electrical device. One afternoon in his workshop, Bain drove 2 metal rods into the damp soil behind his building, 1 copper, 1 zinc, connected a wire between them and attached a small galvanometer. The needle deflected. A sustained, measurable current was flowing from the earth itself. Bain filed a patent that same year, British Patent 9363, for what he called the earth battery. He understood immediately what the discovery implied. If moist soil could complete an electrochemical circuit between 2 dissimilar metals and produce a sustained electrical current, then the entire surface of the planet was, in principle, a power source. No fuel, no combustion, no steam. Just 2 pieces of metal and ground. He spent the next 2 years scaling the discovery. By 1843, Bain had demonstrated that earth batteries could power telegraph lines across open countryside without any conventional power source. The telegraph was the most advanced communications technology of the 19th century, the equivalent of the internet in terms of its transformative effect on how information moved between cities and nations. And Bain had just proven it could run on dirt. Bain was not alone in making this discovery. 50 years later, in 1892, a farmer in Murray, Kentucky named Nathan Stubblefield buried metal coils in the ground around his property, connected them to a receiver of his own construction, and on a cold January morning transmitted his voice wirelessly across his farm. No power line, no battery pack, no generator, earth batteries driving the entire system. The local newspaper described it as a miracle. Stubblefield demonstrated the technology again in Washington, D.C. in 1902, transmitting voice across the Potomac River in front of witnesses. He died in 1928, alone and penniless, in a shack on his own property. His patents expired and his technology undeployed. Go back further still, approximately 2,250 years before Bain's workshop. In 1938, archaeologists excavating a site near Baghdad discovered a clay jar roughly 5 inches tall. Inside the jar was a copper cylinder with an iron rod suspended at its center. The artifact dated to approximately 250 BC. When researchers at General Electric filled a replica with grape juice as an electrolyte, it produced between 1.5 and 2 volts of electricity. The Baghdad battery, 2,000 years before Volta. Someone in ancient Mesopotamia had discovered that 2 dissimilar metals separated by an acidic liquid produce electrical current. The principle has not changed in 22 centuries. In 1848, the United States government itself documented the use of earth batteries to power sections of the early American telegraph network. The documentation exists in official reports filed with the Smithsonian Institution. This is not fringe science. This was federal infrastructure. Soil-powered electrical generation was a documented functioning component of the communication system of the United States government in the mid-19th century. And then, without public debate, without scientific refutation, without any announcement at all, the earth battery disappeared from the conversation. Not because it stopped working, not because something better replaced it for the same cost, because something more profitable replaced it for a dramatically higher cost. This technology was superseded by more profitable, albeit higher cost alternatives that eventually dominated the market. Now let me show you exactly why this works. Because the physics is not complicated, and understanding it will broaden your perspective on electricity generation beyond conventional industry offerings. The principle is called galvanic corrosion, and it is one of the most thoroughly documented phenomena in electrochemistry. When two metals with different positions in the electrochemical series are placed in contact with an electrolyte, any liquid that conducts ions, electrons flow spontaneously from the more reactive metal to the less reactive metal through any wire connecting them. This electron flow is electrical current. It is the same principle that powers every battery ever manufactured. The difference is that a conventional battery uses a carefully controlled electrolyte, sealed in a manufactured container, while an earth battery uses the ground itself as the electrolyte. Soil is a natural electrolyte. It contains water, dissolved mineral salts, organic acids produced by decomposing plant matter, and billions of microorganisms whose metabolic activity enhances ionic conductivity. Forest soil, garden soil, any soil that retains moisture contains all the ionic components necessary to complete a galvanic circuit between two dissimilar metal electrodes buried within it. The voltage produced by a single galvanic cell depends on the electrochemical potential difference between the two metals used. Zinc and copper, the most commonly available combination, produce approximately 1.1 volts per cell. Magnesium and copper produce close to 2 volts. Aluminum and copper produce approximately 1.5 volts. A single cell at these voltages is not sufficient to charge a modern phone, which requires 5 volts delivered through a USB connection. But cells connected in series add their voltages together. 5 zinc-copper cells in series produce 5.5 volts. 10 cells produce 11 volts. The mathematics is straightforward, and the scalability is limited only by the number of electrode pairs you are willing to install. A study published by researchers at the University of Wisconsin in 2017 measured sustained current output from soil-based galvanic cells over a 90-day period. The cells showed less than 12% degradation in output over 3 months of continuous operation. For comparison, a conventional alkaline battery sitting unused on a shelf loses up to 20% of its charge annually simply through internal chemical self-discharge. Soil batteries, left undisturbed in moist ground, do not self-discharge. They generate current continuously as long as the soil remains moist and the electrodes remain chemically active. The United States Department of Agriculture has published soil conductivity surveys showing that most forest soils in North America have electrical conductivity between 200 and 800 microsiemens per centimeter, well within the range needed for effective galvanic output. In practical terms, this means that the ground under any average campsite, any garden, any patch of forest, any roadside verge, is already functioning as a galvanic electrolyte. It is already generating a potential difference between any two dissimilar metals placed within it. The electricity is already there. What has been missing is not the power source, but the knowledge that it exists. Now here is where the story becomes very uncomfortable for the portable power industry. The global battery market is a significant industry, providing devices with varying lifespans and replacement needs. The average American household spends over $150 per year on disposable batteries alone. Multiply that across 130 million American households, and you begin to see the scale of the revenue architecture built on the premise that portable electricity requires purchased technology. An earth battery system using 10 zinc-copper electrode pairs, enough to produce approximately 10 to 11 volts for USB charging, can be assembled from materials costing less than $5 at any hardware store. The copper comes from 14-gauge solid copper wire sold by the foot. The zinc comes from galvanized steel nails, whose zinc coating is the negative electrode. The electrolyte is the soil you push them into. A $2 voltage regulator steps the output down to the 5 volts required for USB charging. The entire system fits in a small bag, weighs almost nothing, and the fuel source is the ground itself. You cannot patent the electrochemical series. You cannot patent the galvanic potential difference between zinc and copper. You cannot create a subscription model for two metals that any hardware store sells by the pound. You cannot build a $150 billion industry around something that a 12-year-old can assemble in a backyard with a handful of nails and a piece of wire. The portable power industry has largely focused on manufactured solutions, leading to the Earth battery being less known in modern contexts. The Earth battery does not appear in survival manuals because survival manual publishers sell advertising to battery companies. It does not appear in outdoor gear catalogs because outdoor gear catalogs sell portable power banks. It does not appear in emergency preparedness guides because emergency preparedness guides are written in a cultural context where electricity means purchased technology, and the idea of generating it from soil reads as fiction rather than engineering. The knowledge was not buried in a vault. It was left in the open in Bain's 1841 patent, in the Smithsonian's 1848 reports, in Stubblefield's 1902 demonstration on the Potomac. It was simply never mentioned again in any context where the people who needed it would encounter it. This historical oversight has significant implications for how we perceive power generation today. Here is exactly what to do. This is the part that no battery retailer, no outdoor gear company, and no emergency preparedness organization has ever included in any guide they have published. Go to any hardware store and purchase 14-gauge solid copper wire and 3-inch galvanized steel nails. The copper wire costs approximately 20 cents per foot. The galvanized nails cost approximately $2 for a pound, containing several hundred nails. You will also need a $2 voltage regulator module, available from any electronic supplier or online retailer that accepts between 5 and 30 volts input and delivers a regulated 5-volt USB output. Total material cost for a 10-cell charging system is under $5. Cut the copper wire into strips approximately 6 inches long. You need 1 copper strip and 1 galvanized nail per cell. For a 10-cell system producing 10 to 11 volts before regulation, prepare 10 copper strips and 10 galvanized nails. Find a patch of ground with moist, mineral-rich soil. Forest floors, garden beds, and areas near water sources are ideal. Avoid sandy or very dry soil. Conductivity drops significantly in low moisture conditions, though you can correct this by pouring water over the electrode sites. Push 1 copper strip and 1 galvanized nail into the soil approximately 4 inches apart, burying them at least 3 inches deep. That is 1 cell. Now connect the cells in series. Run a short wire from the copper strip of cell 1 to the galvanized nail of cell 2, from the copper of cell 2 to the zinc nail of cell 3. Continue this pattern for all 10 cells. Each connection adds the voltage of the next cell to the running total. Now you know how to collect it. If this vault changed how you think about electricity, about batteries, and about what you actually need when the power goes out, subscribe and share this now. Every share keeps $1 Miracle digging in the places the energy industry hoped we would never look. The next vault opens soon, and what is inside has been dismissed as impossible for decades by an industry that cannot afford for you to discover it works.